This video will cover setting up an actor by processing the range of motion. After you have captured the range of motion, we need to process the data we captured. You can't open a file in Blade while connected to a system. So rather than disconnecting from the system, I'm going to open another instance of Blade. Now we can open the ROM we just captured. We do this by opening our data management editor. You will notice Blade opens the last loaded database. Be sure to click on the drop-down next to the session to view the saved X2D. If for whatever reason you don't see a file there, you can try right-clicking and going to refresh or verify you are in the correct database. To open the file, we double-click on the blue X icon. You will notice in the camera view you can see some 2D data, and when I scrub through the time bar on the take, the data will move. At this point, we have loaded in the camera calibration file as well as the X2D data for each camera. Now we need to process this data so we can set up a skeleton for our actor. Open the labeling editor. Since we're setting up an actor, it makes sense that we would want to be in the Setup tab. We're going to work our way down, and the first thing we have to do is reconstruct. While Blade is connected to the system, it can reconstruct the markers in real time. This is a recording, so we can't use those real-time algorithms to reconstruct the markers. Although, after an actor is set up, we will have the ability to use those algorithms. Before we hit reconstruct, let's make sure our settings are okay. The reconstruction editor holds all of the settings the system will use when we try and reconstruct a take. I won't go over all these settings in the video, but a detailed description can be found by using the search. I recommend going through that help document and getting familiar with the settings. It can make a difference in the data you see after you reconstruct. I'm going to click Reconstruct. Blade is going to go through each frame and use these settings to reconstruct the markers. After it's done, you can scrub through the take at the bottom where the play range is. The main thing you're looking for here is that the reconstructed data looks good. If there are a lot of flickering markers or no markers showing, check your reconstruction settings and try again. Next, we are going to detect labeling clusters. We put this on the actor during our marker setup, and we need to have the system detect this cluster. If you don't have a cluster on the actor, then you can skip this step. Click the drop-down arrow to show some settings. Two main settings to look at are min markers, which we want to make sure matches the amount of markers on the cluster. The next one is max distance. This is the furthest distance between two of the markers on the cluster. You may need to increase this value if two of the markers are at a greater distance than 100 millimeters. Click the button. If the detection worked, it will look like this. If it didn't work, check your max distance setting. Now we need to create a labeling setup. Click the arrow to view the settings. Here you can customize the setup a bit. If we had finger markers, we could tell the system to create a labeling setup with fingers. If you have multiple actors, you can change the color of the skeleton and sticks, which you will see when we start labeling. Before we click the button, select the markers for this actor. The box that shows after you click the button is where you name the skeleton. I'm going to put in the actor's name and click OK. You'll see some bones appear in the center of the marker cloud. This is the labeling skeleton. We can now have the system label the markers that have been reconstructed. Be sure you're on a frame where all the markers are showing and are also in a T-pose. The system will automatically label the markers. After it's done, we want to go through and make sure that the auto label didn't have any mislabels. There are a couple ways to scrub through the take. One way is to click and hold the arrow as you go back and forth. The other is while you are in the perspective view, you can click and hold down the scroll wheel on the mouse and move it from side to side. Lastly, you can just scroll the mouse wheel up or down to go frame by frame. This is very useful when trying to get on a specific frame. To help the manual labeling, we are going to open the graph view. To move around the graph, you click and hold the left mouse button to pan left and right. If you click and hold the right mouse button, you can expand and shrink the graph. The last thing we are going to do is switch from the Setup tab in the Labeling Editor to the Labeling tab. This is where all the manual labeling settings are. Now let's scrub through the take. We are looking for any markers that might have come unlabeled or any markers that have been labeled incorrectly. The first thing I notice is an unlabeled marker, where the C7 marker should be. There are two different ways we can label this marker. Expand the manual labeling options and you will see two different modes, Select and Label. If we are in select mode, then we select the unlabeled marker first, and then pick which marker that is in the labeling list. Next, we can use the label mode. Here you select the marker from the labeling list first, then you select the unlabeled marker. Either mode is fine to use, just be aware of which one you're in. Below the mode is direction. This tells me which way manual labeling is going to go. For example, if I label with just the forward arrow selected, then it will only label the marker from this frame and on. You can notice this by scrubbing back and looking at the graph view of the unlabeled marker. I want to be sure and label this marker on the first frame that it came unlabeled. Although you can have the labeling go in both forward and backward, I would suggest keeping it going one direction and be sure to start your labeling on the very first frame of the marker's trajectory. Let's continue to go through the take. If you take a look at this marker's graph, there is some data in between. Let's check this data. This is a good example of a marker getting mislabeled. Instead of just deleting the data, I'm going to unlabel it. You do this by selecting all the points in the graph that you want to unlabel, and at the bottom under the manual labeling tools, there is an unlabel section. We want to unlabel the ranges we have selected. At this point, we don't see anything else we can fix, so we are going to the next step in our setup process, which is calibrate. Blade is looking at the range of motion and adjusting all the parameters, joint rotations, and covariances for the labeling skeleton. After the calibration is complete, the system will automatically show you the covariances for each marker, which are these opaque spheres here. You will notice that the hip and chest have two very big covariances. This tells me that at some point in this take, there was a mislabel for those two markers. The easiest way to find and fix this is to select the marker and look for the problem in the graph view. You can see a noticeable difference in the graph here. To fix this, I'm going to cut the keys. Select the points in the graph and then hit Ctrl plus Alt and right click. This brings up a shortcut menu, and at the top is Cut Selected Keys. Next, select the hip and find the problem in the graph view again. Now, after I recalibrate, the covariances look correct. We have finished the setup for our labeling skeleton, and now we need to set up a solving skeleton. We simply do this by going to the solving editor here. Here we see that Owen, our actor, is in the drop-down list. If we did a multiple actor ROM, the other actors that we calibrate in this scene would show up here. Below that is Create Solving Setup. But before we click that, we want to make sure our setup type is set properly. There are two options: Create from Labeling Setup and Production. If you are using a custom marker set or something that deviates from the 53 marker set, you would want to copy from Labeling Setup. In this case, we are using the 53 marker set, so we are going to use the Production Setup. Click the Create Solving Setup button. You will notice a new skeleton appears. This is the solving skeleton. The last thing we have to do is be sure to save out both the VSK and the VSS. Open the Character Management Editor. Next to our actor, we notice that the labeling setup says calibrated and the solving setup is present. Click Export to save out the files. Be sure to save them in the correct file path. The first one you are saving is the VSK. I've already saved it out, so I'm just going to cancel. After it saves, it prompts to save the VSS. Now our actor is ready for real time. Thanks for watching. If you have any questions, please email support@vicon.com.